Welcome to doassignment-ca. Here is the problem. A 200-kilogram crate rests on the ground. The coefficients of static and kinetic friction are μs equals 0.5 and μk equals 0.4. A winch delivers a horizontal towing force T to its cable, which varies as T equals 400 times T to the 1/2 in newtons, while T is less than or equal to 800 newtons, after which T remains constant at 800 newtons. The cable is doubled, meaning 2 cable segments pull the crate, so the net horizontal force on the crate is 2T. Initially, the tension is 0. Determine the speed of the crate at T equals 4 seconds. Now let us work through the solution step by step. Because the towing force is purely horizontal, the normal force simply equals the crate's weight. 200 kilograms times 9.81 gives 1962 newtons. The maximum static friction that must be overcome to start moving is μs times n, which equals 0.5 times 1962, giving 981 newtons. Here is the free body diagram of the crate. The weight W equals m times g acts downward, and the normal force n acts upward. Because the cable is doubled, 2 segments attached to the crate, the net horizontal pulling force is 2T directed to the right. Kinetic friction opposes motion and acts to the left. The crate starts to move when 2T exceeds maximum static friction of 981 newtons, so T must equal 490.5 newtons. Setting 400 times the square root of T naught equal to 490.5, and solving gives T naught approximately equal to 1.504 seconds. We also check when T reaches its cap of 800 newtons. Setting 400 times the square root of T equal to 800 gives T equal to 4 seconds, exactly our target time. So throughout the entire sliding phase, from T naught to T equals 4 seconds, the tension follows the rising curve T equals 400 times T to the 1/2. Once the crate is sliding, kinetic friction applies. μk is 0.4, so kinetic friction equals 0.4 times 1962, which is 784.8 newtons. The net force on the crate during motion is 2T minus kinetic friction, 800 times the square root of T minus 784.8 newtons. We apply the impulse momentum principle. The crate has 0 velocity initially and remains at rest until T naught. Integrating the net force from T naught to 4 seconds gives the change in momentum, which equals 200 times the final velocity v. Integrating 800 times T to the 1/2 minus 784.8 gives the antiderivative 1600 over 3 times T to the 3/2 minus 784.8 times T. Evaluating at T equals 4 seconds, 1600 over 3 times 8 minus 784.8 times 4 equals 402 and 66,667, 67 minus 3139.2, which is 127.47 newton seconds. Evaluating at T naught of 1.504 seconds, 1600 over 3 times 1.8443 minus 784.8 times 1.504 equals 983.0 minus 1180.0, which is negative 197.0 newton seconds. Subtracting the lower limit from the upper limit gives a total impulse of 1127.47 minus negative 197.0 equal to 320.24.47 newton seconds. Dividing the total impulse of 324.47 newton seconds by the mass of 200 kilograms gives the final speed, approximately 6.62 meters per second. This is the speed of the crate at T equals 4 seconds. To summarize, the normal force is 1962 newtons, maximum static friction is 981 newtons, and the crate begins moving at approximately 1.504 seconds. Kinetic friction is 784.8 newtons. The total impulse from the start of motion to T equals 4 seconds is 324.47 newton seconds, giving a final speed of approximately 6.62 meters per second. As a quick check, at T equals 4 seconds, the net pulling force of 1600 newtons far exceeds kinetic friction of 784.8 newtons, confirming the crate is still accelerating at that instant. Visit doassignment.ca for more study tools, AI learning support, and online tutoring.